And then they'll let you choose the next one. Two cars start moving from the same spot. So notice what I do. I read sentence by sentence. Two cars start moving from this. Two cars start moving from the same point. Okay. One travels south and the other one west. Okay. So this is the point. One south and the other one west. Okay, go back. The one that travels south travels at 60 miles per hour. 60 miles per hour. The one that travels west travels at 25 miles per hour. At what rate is the distance between the cars increasing 2 hours later? So 2 hours later, distance between the two of them. Okay. So here are our cars. They start at the same point. One goes faster this way and one slower west. At some point in time, I say, let me see what the distance is. Okay, this is the distance between the two cars at any point in time. So they start here at the same time. At any point in time, it doesn't matter when, this is the distance between the two. They're asking us at a particular moment that I don't care about at this point. I need to determine how fast is this distance changing when they continue driving, but at a particular instant, 2 hours from the moment they started. So in order to determine the rate of change, I first have to picture what I'm discussing here. This is basically for X, this is for Y. I'm going to call this W. So the first car, or the one going west, drives at 25 and the one south at 60 miles an hour. But I'm really asked to determine the rate of change of this. So what am I really asked to find? If I'm asked to find the rate of change of W, what should I write? What am I really asked to find? How do we express the rate of change of a function with respect to time? For W, what am I really asked to find?
Is it dw dt?
Of course, this is what I'm asked to find. Excellent. At a particular instant, when time is 2 hours, we will never put this into calculations till the last moment. Because remember, I have to find the function, the derivative, before I plug in anything. If I don't find the derivative, I can't plug in anything. So first I have to find dw over dt. Before we do that, let's analyze what this represents. Let's analyze what this represents. I have not identified what these represent. I'm going to call this x, and I'm going to call this y. Y because it's vertical, and x because it's horizontal. So can anyone tell us what 25 miles per hour represents? And I'll put it here. What does 60 miles per hour represent? And I'll put it here. Try it. It's okay if you're wrong.
Is it dx dt and dy dt?
Of course. Of course. Because miles per hour, it's a function of time, right? Distance with respect to time. It's a rate of change. So it has to be dx over dt. It has to be dy over dt. Miles per hour. Once we establish this, and because I see a right triangle, I can write a relationship. I have to write an equation that relates x to y and to w, and they're all functions of time, but not yet. I need an equation that connects all three, and then I will differentiate with respect to time. Can anyone give us an equation that relates, that connects these three?
A squared plus B squared equals C squared.
Very good. But always remember, a leg squared plus another leg squared equals the hypotenuse squared. Just to make sure. So x squared plus y squared equals w squared. Awesome. So I have the relationship. And now I have to differentiate both sides, keeping in mind that x is a function of time, y is a function of time, w is a function of time. Who would like to try to differentiate both sides with respect to time?
Would it be 2x dx dt
Brilliant.
plus 2y dy dt equals 2w dw dt?
Excellent. Of course, I'll divide both sides by 2. It's an equation I can divide by 2. And can anyone tell us what is our unknown? What are we solving for?
dw dt.
Exactly. So dw over dt equals, after I simplify both sides by 2, equals this dx plus y dy over dt over w. So x dx over dt plus y dy over dt over w. Only now I will say when t equals 2 hours, because I have the function. Once I have the function, I can plug in. I don't have x. We'll calculate in a minute, but I know that this is 25. I don't have y. We'll calculate in a minute, but I know that this is 60. I don't have w, but I know that w is the square root of x squared plus y squared. Once I determine x and y, I can plug them in. So this is uniform motion. It goes this way for 2 hours. What is the distance covered? It goes this way for 2 hours. What is the distance covered? So we want to find x and we want to find y after 2 hours. How much is x after 2 hours and how much is y after 2 hours? Knowing that the speed here is 25 miles per hour and the speed here is 60 miles an hour. If you drive at 25 miles an hour, how far away are you in 2 hours?
50.
Yes, 50 miles, awesome. If you're driving at 60 miles an hour, how far are you going to be in 2 hours?
$120.
That's it. So then now we have everything. X is 50. Y is 120. And this is the square root of 50 squared plus 120 squared. I know it's all over the place. I'm going to write it again, of course. So I'm going to copy everything step by step. So dw over dt when t equals 2 hours is 50 multiplied by 25 plus 120 multiplied by 60. Everything divided by the square root of 50 squared plus 120 squared. Since I need a final answer approximated, I'm going to do this. Please do that in one step with parentheses. So we have 50 multiplied by 25 and plus 120 multiplied by 60. Close the parenthesis and divide by the square root. And the square root, you know I love my parentheses. 50 squared and then 50 squared, and then plus 120 squared, and close the parenthesis. When I hit enter, what am I getting and what is the measurement unit? What is the measurement unit?
Miles per hour.
Of course, thank you. So again, what did we accomplish here? We said this. So when these two cars go their way at their respective speeds, exactly at the exact instant, 2 hours from the moment they start, this distance between the two cars changes with the rate of change, if you want, at 65 miles per hour. At that instant, 2 hours from the moment they started, the distance between the two of them, the rate of change of distance, is 65 miles an hour. Any questions? Any questions? This is the end of chapter 3, but we need to practice more. Okay, so let's take a look at what about 26? A particle moves along a curve y equals. Oh, I forgot to ask. Did you want to choose something else? So a particle moves along the curve. Fine, I copied the function. As the particle passes through the point 1/3, 1, you know that this is a trap, right? Because it's when, or at the moment. We will never consider this till the very end. Okay? Its x-coordinate increases at a rate of the square root of 10 centimeters per second. How fast is the distance from the particle to the origin changing at that instant? Okay, so first of all, let's analyze what this means. The x-coordinate increases at a rate of the square root of 10 centimeters per second. What does this represent? Because if I don't know what this represents, then I will not be able to continue. And then we will graph and discuss the situation. But first we have to identify what this means. So the rate of change of the x-coordinate with respect to time is the square root of 10 centimeters per second. So what is this? How do I express this piece?
dx dt.
Of course, the rate of change, thank you so much, dx over dt. So this is given to us. This is a point at the instant. So be very careful. This is a trap. Please, careful. Every time you see when or at the instant, such and such, this is a trap. Like it was here. This was a trap. Because we could not use this information till we determined the function, the derivative of w. We needed the derivative of w first in order to plug this in. Okay? Good. So the function with to sine is something like this. And the particle moves along the curve. And now at a particular instant, not this one, any instant, let's say the particle is here, the distance between the particle and the origin is this. Of course, this is the y. Of course, this is the x between this and this. and we are asked to determine, I'm going to use W for the distance. They're really asking us what? Okay, let's go back to the problem one more time. So a particle moves along the curve, fine. As the particle passes through the point, okay, its x-coordinate increases at a rate, so it increases means it's positive. Good. How fast is the distance from the particle to the origin changing at this instant? So what is the question here? What am I asked to find? It's basically the same problem with the one from before. What am I asked to find? I need to determine this. But I need to identify what it means. How fast is the distance between the particle and the origin changing at a particular instant? But I need to identify what it is that I'm asked to find. What am I asked to find?
Is it also dw/dt?
Oh, of course, yes. dw over dt, of course. Again, the same idea. That's why I chose two similar problems, so you can understand even better, hopefully. So what is the relationship? And this is a function of time, this is a function of time, this is a function of time. What relationship will you write among these three?
X squared plus y squared equals w squared.
Very good. Leg squared plus leg squared equals a hypotenuse squared. I'm going to differentiate exactly the same thing, dx over dt plus 2y dy over dt equals 2w dw over dt, everything the same. Again, I'm after dw over dt. Again, the same thing, dw over dt. After I simplify both sides by 2, I shouldn't be writing this. It's not okay. You know me, I don't like that. But you can write on the side we are dividing all terms by 2. That's okay. So x dx over dt plus y dy over dt divided by w. All we need to do now, find all those numbers and plug them in, and it's done. So, and now I can write when x is 1/3 and y is 1. So this is very easy to find w, because w will be the square root of 1/3 squared plus 1 squared. That's done. I know that x will be 1/3. I know that y will be 1. And all we need to determine now, and we also have dx over dt. It's given to us. This is the square root of 10. But what we need to determine is dy over dt. No problem. Can anyone differentiate this function for us? Let me write it here one more time. Y equals 2 sine pi x over 2. So we want to find dy over dt, keeping in mind that y is a function of time and x is a function of time. I like to emphasize that. You don't have to put those dots if you don't want to. I just want to re-emphasize that these are two functions of time, and I will differentiate both sides. What would you say this equals to?
Pi times cosine of pi x halves.
So we have 2. Yes, but I need to show everything. You're right. 2 sine prime is cosine pi x over 2 times pi over 2 times dx over dt. So 2 is a constant in front. Sine prime is cosine of the same argument. Then we differentiate this. We get pi over 2. Then we differentiate the innermost function, which is dx over dt. So in order to put, this is what we are after, and everything else is there, right? So in order to determine this, I will have to say that when x is 1/3, and dx over dt is the square root of 10. So 2 pi over 2 times 1 over 3 is pi over 6. Cosine pi over 6 is the square root of 3 over 2 times pi over 2 and times the square root of 10. Again, 2, 1 over 3 times pi over 2 is pi over 6. Cosine pi over 6 is the square root of 3 over 2. I have to copy pi over 2, and I am given this the square root of 10. Yes, I will simplify these two. So I have pi the square root of 30. And this is centimeters. What was it? Yes, centimeters per second. Correct. So all I have to do, I know it's time. If you need to leave, that's fine too. I just need to write the final answer here. That's all I need. Another 30 seconds. But if you have to leave, I fully understand. So we have 1/3 the square root of 10 plus pi the square root of 30 times 1 divided by the square root of 1 over 9 plus 1. So I will determine this number, and that's it. Where is my shared screen? Okay. Be very careful. Numerators and denominators have to have parentheses. So parentheses, the square root of 10. Make sure you are completely out. Divide that by 3. And then plus pi. And multiply that by the square root of 30. And then completely out. Close the parenthesis. And then divide by the square root. And I like parentheses there. I have 1 divided by 9 and plus 1. And close, and I press enter, and that's it. So this is 17.32, and this has to be centimeters per second. Thank you. Sorry for keeping you another minute.